Welcome to Aerotech's Automation1 Motion Control Platform educational series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, we will take a look at critical sections and their uses. My name is Chris Charlesworth, and I am the European Control Systems Engineer for Aerotech. First off, what is a critical section? A critical section is a section of code which is guaranteed to be executed once per millisecond. 1 millisecond is the controller period, as the controller operates at 1 kilohertz. So the main uses for this are normally to do with trajectory generation, whereby we're doing a series of calculations that are then giving out a motion trajectory. So we're going to use one of the example programs that we provide within the help file. Now, this help file program is the PVT motion example. You can find it under Develop Your Process, Aeroscript Programming Language, and Aeroscript Example Programs. There's a nice list of them in here, and the PVT motion is what we're going to use. This piece of code demonstrates how you can create an oscillate command, which can then be used to oscillate various different axes. Now, I have already copied this code directly into Automation1 Studio. I've also made some modifications so that we can do these examples really nice and quickly. Now, the biggest question I get asked about critical sections is, how many lines of code can I put in a critical section? And I had a conversation with our R&D engineers, and the answer was, it depends. However, we do have a way for you to work out whether or not you are approaching the limit. So, I've opened up the status utility. This is one of the standard programs we make available to you when you get hold of the machine development kit. On the left-hand side of there is something called the controller, and this brings up a series of controller status items. Now, what's very important here is in the center under performance. And what we're going to watch is the process usage average. We can see at the moment it is hovering around about 12 or 13%. What we're going to do is run this program for about 10 seconds, and we're just going to watch this number. The program in this particular case is going to make an oscillation on the x-axis, and it will oscillate at approximately 5 Hz, and it will do 50 cycles. You can see I've actually queued this up to do X and Y, and that's to show the next stage of this demonstration. So I'm going to hit play on this. Then you can see suddenly this number's increased to over 20% and topping out at about 26. That was a short little program. You can see it's still running, and it's now ended. So if I were to look into the visualize workspace, you can see the oscillation moving backwards and forwards on the axis. There we go, that was about 26% we topped out at. Now down here I have a piece of code commented out. I've copied the code and replicated it for another axis. In this case it's going to be the y-axis. Now we're going to run this again. I'm going to hit play, and you can see the number is still topping out about 25 or 26%. So you can do quite a few calculations within the 1 millisecond timeline. This is a trajectory for 2 axes. It is possible, of course, that I could keep increasing this until we eventually start to increase the processor usage. However, in this case, what I've done is added in one final calculation with a repeat line. So we can repeat this once, or we can repeat it 10 times or even 100 times. To start with, we're going to do a 10 times repeat. Now, this calculation is just a line copied from above, and it's just to work out the oscillation velocity. So it's pi times the frequency times the distance times the cosine of a load of gubbins just there. So you can see it's quite a complex calculation. You've got 1, 2, 3, 4 steps, 5, 6, 7, 8, 9 or 10 different steps within that calculation. So that's relatively computationally intense. We'll hit play again, and we'll keep an eye on that magic number, and you can see we've now gone up to into the 30s. We're at about 35% by executing that line 10 times. Now, why am I showing you this? Well, quite simply, the number of lines that you can put inside a critical section are down to how complex that code is, how many calculations, and what are you doing within it. So you can never really know exactly what's going to happen. What we can do is use the status utility and look at the process usage. And we can then take a look and see how much we're using. And if we're starting to use too much, we can start to try and reduce that. So if I now repeat it 20 times, let's have a look and see what the processor usage being. We're now into the 40s. Now, if I were running this just for a short program, I'm not going to worry too much even if I hit 100%. However, when the processor usage average is maxed out, you're using up all of the processing power just inside the critical section, meaning that other parts of the program are likely to start failing. So for that reason, I would probably limit myself to a maximum of 50% as a starting point. And even at 50%, I would want to do a lot of testing about this critical section and about what's happening. Theoretically, a faster processor running would allow you to put more lines of code in, but it all comes down to a lot of very small, nuanced items. So the simplest thing to do is do it empirically and have a look at the processor usage to see where you are. That concludes this Automation1 educational video. Thank you for watching. I hope you enjoyed learning about critical sections.